So just look at how you have to use it. Suppose I am stating an example for you. It is CH3, CH2, C, CH2, CH3. We have CH, again CH, 3, we have CH3, then again we have CH3, right. So the first rule is that we have to just select the parent chain, right. So which chain we are going to select? 1, 2, 3, 4, 5 carbon, 1, 2, 3, 4, 5, again 5, 1, 2, 3, 4. So that means we are going to select the straight chain, because we know that we have to select that chain which is continuous, which include maximum number of carbon atoms, and also what should be the criteria, that it should be maximum substituted or alkylated, as we get to see many alkyl groups. So now the second rule is that the chain, the groups which is left, you can say after the parent chain, after including the atoms in the parent chain, they are considered to be a substituent, right. So these are the substituents. Now how I am going to number it? We know that we have to number in such a manner that a substituent should get the lowest number. As you get to see that these are placed as a single group, so that means it is a ethyl group. It is a methyl group, obviously it is again a methyl group. So that means if I number from this side, this thing 1, 2, 3, 4 and 5, then the substituent are getting 3 number, as we can see 3 ethyl, 3 again methyl and 4 again methyl, means the positions are 3, 3, 4. But if I number from that side 1, 2, 3, 4, 5, then what do I get? I get it at 2 position, this methyl group, I get 3 and 3 positions. So that means if I use the lowest set of locant, this is preferred, because see this out of 3 and 2, 2 is smaller, you know that. So that means this numbering is preferred, right. So I will just make again repeat it, so that you should know that how you have to just name it. So it's like that. We have the ethyl group, and here we have the CH3. So I told you we have to number in the order that it is 2, 3 and 3. So this is the same way I am just numbering it. I will draw it with a different pen. 1, 2, 3, 4 and 5. This is the parent chain and this is the numbering done. Now when we are writing the name, we know that it is written prefix, word root, primary suffix, secondary suffix. So just look at for the word root, that means the number of carbon atom in a parent chain. 1, 2, 3, 4, 5. So how many carbon atoms? 5. So word root uses pet, right. Now we look for the prefix. So we say that at 2 there is a prefix this, we have 3 the prefix this, right. So we have in this order. So now when we will be numbering it, when we will be naming it, what we will be doing, we will be indicating the position, that is the 2 methyl, right, 3, 3, 3, 3, methyl, see at 3 you get to see ethyl also, you get to see methyl also, right. But when you have to specify, we will write in alphabetical order, we will write the name of the substituent whose letter starts first or which comes first in alphabetical order. So that is ethyl. So it is 3, 3, ethyl, methyl, this is pent, primary suffix all single bond, that is ane. So this is going to be the IUPAC name, that is 2-methyl, 3,3-ethyl methyl pentane, right. So or we can write in either way, because when we, do you think that it is a correct one? We can write in a proper manner. It's like that when we write, we just count this methyl group together and ethyl group not included with them, right. So what we get to see, we can write that it is, first we know out of ethyl and methyl E comes. So we write it is 3-ethyl, next we have 2 and 3. What we have on 2 and 3? 2 methyl groups. So I can write dimethyl, you have pentane. So the correct naming is not like this, it is this. So see, as you can see, what is the difference between them? It is just the difference of rearranging them, right? Because we know that the substituent whose letter starts or which letter comes first in alphabetical order is written first, then followed by the other one. So the perfect name for it is 3-ethyl, 2,3-dimethyl pentane, right. The second example which I am stating for you is this. Suppose you get to name this compound. So how you will be doing it, right? What examiner do, what kind of tricks they use in a question is that when they will give you these kind of questions, they will just you can say count the carbon atoms together in a molecule, and what you do, you actually are so used to it that you just number them in this order. You don't have practice of just opening the structures if they have more than one carbon atoms, and you fail in doing or you can say you fail in attempting this kind of question. So just keep in mind, if you get this kind of question, you can see it is C2H5. So your first step should be that you should open this structure, right? So this is what I am doing here. Just look at board. I am opening C2H5 means CH2 CH3, and again this CH2 CH3. So if I use this chain, if we don't open this structure, what we'll get to see, we are going to select the parent chain, this 4 carbon atom 1. But if we just open a chain, we are going to select this parent chain. See how many carbon atoms are here? 6 carbon atoms. So obviously this is going to be a parent chain. That means opening up the condensed formula also plays an important role while writing an IUPAC. So this is how you can see that in above one it was 4, and the second one it comes out to be 6. That means it differ in the word root as well, right? That means if we select the first one, we are going to use the word root but, and if we select this one, we are going to use the word root hex. So it completely you can say completely differs the compound if we do not open this condensed formula. So we need to open the condensed formula while writing an IUPAC, right? Now the second step is that we have to number it. So either I number it from this side or I number it from this side. That means 2 methyl groups are getting the same number, right? That is the 3 and the 4, right? Because these substituents are same, so that means it hardly make a difference that I just start from here or that side. But if they differ in the alphabetical order, then you know that the group whose alphabet comes first in alphabetical order is given a small number, right? So now I am just writing the name, again prefix, word root, primary suffix and secondary suffix. So prefix is 3 and 4. So you just specify 3 and 4 together because they are same functional group. We are going to write di, tri and tert for it, right? So these are 2 methyl groups. So I am going to write 3,4 dimethyl. This IUPAC is actually the you can say a complete address, right? So that, like I am writing 3,4 dimethyl, that means at 3 and 4 there are 2 methyls. That means the 2 similar groups. Right, like if somebody asks you that where your friend stays, she says that yes, this is the house number, this is the sector, and this is the landmark, right? So the similar way we get to give in this IUPAC that we have to name in such a order, we have to address in such a order that by looking at the name, we can just formulate the structure in our mind, that what kind of bonds or groups it possesses. So we are done with the prefix because there is no other prefix left. Word root is hex. Primary suffix, we get to see only single bond, and there is no secondary suffix. So the name becomes 3,4 dimethyl hexane, right? Few more example. Suppose we have this thing. So obviously the first step is to select the parent chain, right? Second is to number it. We get to see this also, C2H5, so that means we'll be opening up 2. Right. So whether we select, if we select this chain, the carbon atom comes out to be 3. But if I select this chain, the carbon atom comes out to be 4. That means my parent chain is going to be this. Right. And second step is to number. So whether I number from this side or that side, obviously the substituent is going to get the minimum number 2 from this side, and from this side it comes out to be 3. So obviously which will be followed? The 2, 1. Now the name 2, 2, again same functional groups, 2, 2 dimethyl, but and ane. So this is how you are going to write the IUPACs for the compound. See, we have started with the simple level. Now we will just gradually increase the level, because once you should know that how we will be attempting how to arrange this prefix, word root and suffix accordingly, and then we will be just increasing the level gradually, so that you should know that how the name gets different when it contains a double bond, triple bond or a functional group, right? So this is a simple level in which there is only alkyl group present.